Hello, this is Marwan Omar, and I'm grateful for the opportunity to be invited as a guest speaker to the CONF-MSS conference. Greatly appreciate the opportunity. A little bit about myself. I am Dr. Marwan Omar. I am an associate professor with the ITM department at Illinois Institute of Technology. I have been with them for only about 6 months now. I started last fall, and before then, I was in Florida working for St. Leo University, also as an associate professor of cybersecurity. I have been in academia for about 12 years now, and I've also had some experience working in the industry with companies like Hewlett Packard and others. I also hold some industry certifications, such as the Certified Ethical Hacker from AC Council, the Sec Plus from CompTIA, another certification from ISACA, Certified Privacy Data Solution Engineer from ISACA, as well as a certification from SANS on smartphone forensics. So I'm a certified advanced smartphone forensic analyst with SANS. Today, my topic will be on the reverse engineering of malware. So let's get started. And here is our agenda. So what we are going to learn in this talk is that we are going to cover automated analysis capabilities of malware. So the big picture here is reverse engineering malware. We want to be able to understand how malware is authored, and when business organizations are faced with cyber attacks that involve malware, which is common these days, how do we handle the situation? How do we start the analysis of the malware? How do we know whether we should do automated analysis or behavioral analysis or even code level analysis? Because these are the three techniques that you can follow as guiding principles when we decide to handle malware. So again, we are going to cover the automated analysis capabilities. How do we analyze malware using automated tools such as VirusTotal, Exchange, Threat Exchange, for example, and others? And then how do we move on to the next phase after we are done with the automated analysis? The next step would be naturally is the behavioral analysis of the malware. How does the malware behave when we let the malware unleash in our controlled virtual environment? And then the last technique is the code level analysis. That's where we dive in and take the malware inside out, so to speak, to understand how the malware was authored and what kind of capabilities are embedded in that malware. For us to make this topic accessible to individuals with a limited exposure to programming concepts, we will cover these concepts, and hopefully even people with limited knowledge of programming, they can relate to this and understand this. So we will learn about the fundamentals and the associated tools to get started with malware analysis. Let's move on to the next slide now. So why learn REM, or reverse engineering malware? So we use the term or the acronym REM, which stands for reverse engineering malware. Reverse engineering malware is an important skill to learn for cybersecurity professionals, because these days many business organizations face cyber attacks. When a cyber attack strikes, it's important to have somebody on the team to be able to handle the situation and start analyzing the malware. So again, security incident responders benefit from knowing how to reverse engineer the malware. And by the way, REM, or reverse engineer malware, is a term that we use exchangeably with malware analysis. So if we say malware analysis or REM or reverse engineering malware, basically we are referring to the same thing. We try to understand how malware is authored, because this process helps in assessing the event's scope, meaning the cyber attack, for example, the severity of the event, the severity of the attack, and the repercussions. What could be the repercussions? Is it financial repercussions? Is it something related to the reputation of the company? Is it something related to the image of the company? Will they face legal consequences because maybe customer data has been compromised, etc.? Learning REM will also help in containing the incident and in planning the recovery steps. If we have skilled and talented cybersecurity professionals who know how to analyze the malware, this will help them containing the incident and also planning the recovery phase or steps. Those who perform forensic investigations could also benefit from mastering this topic, reverse engineering malware, because they learn how to understand the key characteristics of malware that could be present on compromised systems. Something to note here is that malware could be residing on our networks without our knowledge. Sometimes malware authors will design a piece of malware to attack some network systems, compromise them, and stay dormant for a while. And then that malware maybe can be used to communicate with a command and control server, or CC2, or C2 for short. In this case, sometimes it's hard to know that there's malware on our system. And sometimes malware authors will write malware that will eventually be able to blend in, so to speak. So the way a malware piece could be designed, malware authors can try to break into some network systems and maybe exploit some vulnerabilities on the network, and then maybe create, for example, a username on a specific workstation that belongs to certain employees or users of the company. And then in that case, they can blend in because now they are logging in to our compromised systems as if they are a legitimate user. And that is beneficial to them because now they are blending in. It's harder for us to detect them, and it's easier for them now to avoid our defenses. For example, if we have tools like SIM and Wireshark and other security monitoring tools, it may be difficult to see if there is suspicious activity on the network because everything will look green, everything will look normal because we have legitimate users exchanging information on the network. So that's something to note regarding the mentality or the mindset of hackers these days. Malicious software. What is malicious software? That's basically malware. Malware or malicious software, again, we use these two terms interchangeably. How relevant malware has become in the context of computer intrusions or cyber attacks. Almost every data breach or cyber attack announced publicly, it seems that it will involve some form of malicious software, such as backdoors, trojans, network worms, exploitation, kits, malware, so on. In this session, we will learn about the approaches or the techniques for analyzing malware, for taking the malware inside out. So you can turn malicious executables inside out to understand the inner workings. I believe by learning reverse engineering malware or malware analysis, we can also gain a window into the mindset of cyber hackers or cyber criminals or malware authors. Reverse engineering malware will enable us to understand how they think and what tools they use to gain access to our systems. When a breach occurs, what happens whenever there is a data breach or a cyber attack? When such an intrusion occurs at your organization, you will be able, or will you be able to quickly assess the threat? Knowing how to analyze malware can help you understand the context of the incident, its severity and repercussions. Severity, how severe is the incident? How severe is the data breach? How severe is the cyber attack? Has it only impacted a workstation? Has it impacted or compromised maybe a database server? Do we know if the incident only targeted one piece of the network, one segment? Is it a production environment? Is it the marketing department that has been targeted? Is it the finance department? Is it the CEO of the company, for example? So these are questions that you might be able to answer by analyzing malware. It can help you plan your response, as you mentioned, for recovery to contain the incident's scope, and in some cases understand what entities might be behind the intrusion. Perhaps that is why the individuals who are looking to acquire malware analysis skills are no longer just antivirus and threat researchers. When you become a malware analyst, you're not just an antivirus researcher or a threat hunter, but also system and network administrators as well as general security professionals. So all of these categories of professionals are interested in learning how to analyze malware. More and more often, these individuals are being asked, meaning network admins, system admins, incident responders, cybersecurity professionals, they are being asked to understand the capabilities of the malware that the organizations discover. So again, if a piece of malware compromises a business organization as part of a cyber attack, it's important for cybersecurity professionals, incident response teams, network admins to understand what capabilities does the malware have. How, for example, was the malware capable of encrypting network traffic while communicating with a command and control server? Was the malware capable of exploiting privileges and creating user accounts on our network so that they can blend in? Was the malware capable of deleting software on our networks? Was the malware capable of exfiltrating sensitive business data or confidential data or client data, financial information to a command and control server? So these are questions that we strive to answer when we analyze the capabilities of malware. Now we can talk about the benefits of learning malware analysis or reverse engineering malware. Knowing how to analyze malware can bring an element of control into an otherwise chaotic environment that exists around a security incident. When attackers strike business organizations, things can go chaotic. People get scared. People get nervous because nobody knows what could happen. We don't know the scope, the context. We don't know the severity of the attack yet. We don't know the consequences or repercussions or implications. So that's where having the skills to analyze malware, to take malware inside out, to apply these techniques that we mentioned earlier, static analysis, automated analysis, behavioral analysis of malware, and then code level analysis comes into play and is very beneficial. It is also critically important for modern forensic analysis actions because it's all too frequent for investigators to discover malware on a compromised systems. So even if somebody is working as a digital forensic analyst, they might come across an incident, cyber attack that involves malware. So in this case, digital forensic analysts or examiners or professionals, they will be asked to take that malware to a virtual controlled lab environment and analyze it to understand the capabilities so that you can assess the damage, the extent of the damage that could have been caused by malware. REM approaches and tools. What approaches do we take for analyzing malware and what tools? Something to note here is that we do not try to analyze malware with our brains, with our minds. We try to take advantage of the tools and the applications that are available to us. Many of them are free, some of them are not. There are numerous tools out there that we can utilize to help us do the legwork or the grunt work or the heavy lifting, so to speak, for us. Because analyzing malware can be a daunting task. To help us alleviate some of the challenges associated with analyzing malware, we can take advantage of some of the tools that are publicly available. So the approach to reverse engineering that has worked for many analysts, meaning malware reverse analysts or malware analysts, involves two key phases: automated sandbox analysis, behavioral analysis, and code level analysis. The first approach, automated sandbox, there are some online automated sandbox tools that will help us analyze malware on the fly. This is a good way for us to quickly assess the situation to determine whether or not this is actually malware. And that will inform our next steps as well. So the automated sandbox analysis could be helpful. It's a quick and easy way to assess the situation. However, it has some challenges as well. And then we have the behavioral analysis. That's where we run malware in our lab. So we unleash malware. So we run and execute malware in our virtual lab environment, and we monitor the behavior of that malware. So again, during behavioral analysis, we want to examine how the specimen, meaning the malware specimen or the binary or the executable, interacts with its environment, meaning does it try to access certain artifacts on the system? For example, does the malware specimen try to access registry? Does it try to create files? Does it try to delete files? Does it try to exfiltrate data? Does it try to communicate over the internet with a command and control server? So these are questions that are helpful when we analyze the malware from a behavioral standpoint, looking at the behavior. How does the malware interact, behave when it is in an environment? And then the code analysis phase. It allows us to learn about the specimen's capabilities by examining the code from which the program is comprised. So these are the approaches. Of course, the behavioral analysis and the code level analysis, they can be very time consuming. And especially the code level analysis requires us to step through the code, basically the assembly language, and try to understand how a piece of malware was authored, what is it designed to do. You might be able to gain very valuable insights from conducting code level analysis, again using some free open source tools. However, this could be time consuming, as mentioned. It requires programming skills, it requires understanding of assembly language. Learn REM by doing. A lot of people say the best thing to learn about something is to do it. Learning by doing. We find that the best way to learn malware analysis is by going through examples. So, meaning we are given malware samples or examples, and we try to see how they interact with the environment when we do behavioral analysis. Even before behavioral analysis, we can look at the automated sandbox capabilities of the malware. We can see what capabilities are built into malicious executables. And when we lead you through the analysis, we can introduce tools and techniques that will help you with reverse engineering malware. And in the example that we can show you, we can see that the majority of malicious incidents you will probably encounter, we will be examining a complicated Windows executable for which we had no source code. So if we go here to the internet, and if we just type the name of a malicious malware sample called BRB bot.exe, and if we try to click on any of these automated sandbox tools like Joe Sandbox, for example, this will give us a detailed report about this malware specimen. So we have an analysis report and we're looking at the sample name, which is called brbot.exe, and we're looking at the MD5 hash, then the SHA-1, SHA-256. If we scroll down, we can see here that at the startup, brbot.exe starts, and it has a process ID of 1576. It goes to the desktop, and here's the configuration information, the Yara information, which is a tool that we can use. And if we scroll down, we can see how antivirus engines try to detect this. Then we have the MITRE ATT&CK matrix. We have the behavioral graph. So this is what we were referring to when we mentioned the behavioral analysis. So you run a malware specimen in a virtual controlled lab environment, like a virtual machine. And when you run it, you can see here the behavior graph. How does the specimen behave when it's run? So if we click on it, we can see more information here. We can look at the memory usage, memory allocated, memory activities of after running this BRB bot. This is the process ID 1576, as you mentioned. This is the parent process. It creates another process within it. Of course, all of this to avoid detection. And these are some of the API calls. So we can keep browsing through this to understand how, when was this file created, for example. File written. This is the memory usage by brbot.exe. And this is a high level overview. If we go back to another website, which is another tool called hybrid analysis, it will give us even maybe more information here about this malware specimen. We always have indicators of compromise or IOCs. You can see how antivirus detection, antivirus engines detected this. What are some of the indicators of compromise here? It queries kernel debugger information, anti-reverse engineering. The PE file has unusual entropy sections, and you can look at more details here. So the PE file is packed with UPX. So packed malware, this is common. It reads the active computer name. So if this malware specimen were to compromise the computer, it will read the active computer name, and maybe it will send that information over the network to a command and control server. So there's a wealth of information that we can read here and learn about the behavioral aspects of this malware specimen. Going back to our presentation here, these are some other tools like Virus Total, Payload Security, Threat Exchange. If we click on Virus Total here, it's just another tool. So here, if we have any file, whether it's executable or not executable, we can drag and drop here. If it's a URL, we can even scan it to see if it's malicious in nature. So this is a very helpful online tool. This is free to use to see if there's any suspicious malware. And we have also, for example, Kuko Sandbox. So this is another tool or website for automated malware analysis. And there's the cloud version, or you can even download this sandbox onto your own system. So plenty of tools are available for us to conduct malware analysis. Another one is OSINT, Open Source Threat Intelligence Exchange, is a platform where security researchers and organizations share and collaborate on threat intelligence. The exchange provides access to a variety of sources, including threat feeds, malware repositories, vulnerability databases. By sharing information, OSINT Exchange helps organizations stay informed about emerging threats and develop effective security strategies. We already talked about VirusTotal, which is a free online service that analyzes files and URLs for potential malware threat using over 70 antivirus engines and other detection tools. It provides a quick and easy way to check the safety of a file or URL, making it a useful tool for both individuals and businesses concerned about cyber threats. So we've already mentioned behavioral analysis, which examines the interaction with the environment. We execute malware in an isolated lab system. It could be a virtual machine. We observe and monitor how it interacts with the file system, with the registry, the network, all these important artifacts. So we interact with the malware during behavioral analysis to learn more about specific malware. So when performing behavioral analysis, we infect a lab system with the specimens such as brb.exe, as we talked about. Then we observe how the malicious executable accesses the file system, the registry, the network. And we can also look at the log files. As we learn about the program's expectations, its runtime environment, we can slightly adjust the laboratory infrastructure to evoke additional behavior from the program. And we can try to interact with the program to discover additional characteristics that it may exhibit later. Code level analysis, this is the final stage of malware analysis. It focuses on the specimen's assembly instructions, the assembly code. Disassembler and debugger are critical to code analysis tasks. So these are some of the tools. We can use x64 debugger for our purposes. WinDebug and Radar2 are also among other options for understanding code. Alternatively, you can use API Monitor for the same purpose. So these are some of the tools that we can utilize to help us understand malware on a code level, which is the deepest level of analysis and the most time-consuming. Again, the title of this talk was on malware analysis and reverse engineering in order for us to understand how malware interacts with the environment, what are the capabilities of malware. And we mentioned there are three approaches: automated analysis, behavioral analysis, and code level analysis. And this brings us to the end of this talk. Thank you for the time and attention.